Okay, so in this video, we are finishing the notes for 7.4, talking about the quadratic formula. So just as a reminder, we actually have done the first page of these notes. We did 4 examples with the quadratic formula, and then we also talked about the process up here, practiced singing the quadratic formula, things like that. I actually want to start by looking at what we did previously and point out a few things. So on the first example, when we went through, we ended up with 2 solutions. And this happens oftentimes when we solve for quadratics, or when we solve quadratics, you can have up to 2 solutions. And we actually had that as well on 3 and on 4. Okay. And what I want to also point out is that when we had 2 solutions, if we look at the number under the radical, it was positive every time we had 2 solutions. So that is something interesting. The number under the radical was positive when we had 2 solutions. Versus what happened on example number 2. On example number 2, I had 1 solution, and I got that same solution twice, 1 each time, but really that's only 1 number that's a solution. And the situation that happened was the thing under the radical was 0. So one thing that we are going to be talking about today is how that number under the radical that we find by putting into the calculator is going to tell us about the quadratics that we are solving. And they're going to give us a little bit more information than going through the whole process and figuring it out at the very end. So let's start by talking about just that, the discriminant. So quadratics always have something called a discriminant. And a discriminant has a formula. It's b squared minus 4ac. Now, I've already made you practice the discriminant because that is what you put in the calculator, okay? So again, when I had you solve that in the past, it's what's under the radical, and we find it in the calculator. Okay, so we've always gone through the few examples we did. I had you put the stuff under the radical, just the stuff under the radical, not the radical itself, but just the stuff under it, into the calculator, figure out what that number is. And again, that is called the discriminant. So the part under the radical is b squared minus 4ac. The value we talked about on these examples, 144 and 16 and 0 and 9, is the discriminant of those examples. And now we're going to talk about the discriminant in general. Okay, so here's the situation. When the discriminant is positive or greater than 0, okay, but you can also remember that as like positive values, that tells us what we noticed in the first 4 examples, that you have 2 solutions. And we're not just going to call them 2 solutions, we're going to call them 2 real solutions. That is a mathematical word. You only know of real numbers. Every number you have ever known so far is a real number. So we have 2 real solutions when the discriminant is positive. Then we have a situation where the discriminant is 0. That is something we saw up here as well. On number 2, when the discriminant was 0, we only had 1 solution. And again, it's a real solution. It's the type of numbers that you know up to this point. So 1 real solution. And I do want the word real, okay, because that is important. Then lastly, what happens when the discriminant is below 0 or negative? Well, in that situation, there are 0 real solutions. There are solutions, but they're not real number solutions. And to learn more about that, honestly, you will be doing that next year. Okay, so for this year, all you need to know is that when the discriminant is positive, there are 2 real solutions. When the discriminant is equal to 0, there is 1 real solution. And when the discriminant is less than 0, there are 0 real solutions. And that's actually a pretty good situation because then you don't have to find the solutions. Okay, if you know that there are 0 real solutions, then you just say none and you move on happily with your life. So we're going to now practice the quadratic formula, but also practice the discriminant, and we're going to kind of see what happens. So for questions 5 through 8, it says use the discriminant to find the nature of the solutions for the following quadratics, then find the solution. So again, we're going through the same process we did before, where we need to start by setting the quadratic equal to 0, if it's not already. Now remember, if it's not equal to 0, you replace y with 0. So I'm going to have 0 equals x squared plus 10x plus 25. And what are we told to do first? Oh, just find the discriminant. Okay, so we actually can do less work than we did with the quadratic formula. We just need to find the discriminant as the first thing here. So again, remember the discriminant is equal to b squared minus 4 times a times c, and I guess I can just write 4ac. We don't need parentheses there. So we do need to know our a value, which is 1, our b value is 10, and our c value is 25. So now that we have those values, we can go ahead and find the discriminant. And all you have to do is plug it into that formula. So b squared is 10 squared minus 4 times a times c. And then again, this is the part that you're going to put straight into your calculator. So you need to put that into your calculator, type away, make sure you're using the parentheses, make sure that this is a subtraction sign, not the little negative or you're going to get the wrong thing. And I really want you to practice this and see if you get the same thing I do. So when I put that in my calculator, I got out 0 as the discriminant. So the last thing we need to do with the discriminant is say what type of solutions we're going to have. And again, that is based off of the table up here. So if the discriminant equals 0, we have one real solution. I'm going to write that. So again, I'm going to look for the discriminant and then the conclusion based off that discriminant. And then the last thing we're told to do is we're told to find the solutions, okay? So for that, we need to go back to the quadratic formula, but we do have the discriminant already. So I get to do x equals, Ms. Colbank's going to sing, get ready, opposite of b plus or minus the square root of b squared minus 4ac. We already found that part, 0, all over 2a. Right? And then we can split that up and solve for each individual term. So I would do x equals negative 10 plus 0, because that's the square root of 0, all over 2. Negative 10 plus 0 over 2 is negative 5. And again, we should have the same solution. So let's see if we get the same thing going the other way. Negative 10 minus 0 all over 2. Oh, so negative 10 minus 0 is negative 10 divided by 2 is also negative 5. Do you see how that works? So again, the discriminant lets us know the nature of our solutions, and it will tell us if we have one solution like in this situation because it is repeated. Okay, next up, we have to have 0 where y is. So 0 equals x squared minus 3x plus 10. Then I need to find my a, b, and c values. So a equals 1, b equals negative 3, c equals 10. If you need to pause the video because I'm going too fast, please do. So I need to find the discriminant, b squared minus 4ac. All right, and then I can plug in the different values. Make sure you are checking this in your calculator. So b is negative 3 squared minus 4 times a times c. Again, I would put that into your calculator unless you're feeling brave with your mental math. And then please make sure that you get the same output I do. So when I put that into my calculator, I get negative 31 as my discriminant. Then I can use the table above to help me figure out what that means for the solutions. So when the discriminant is negative or less than 0, you have 0 real solutions. So I can write 0 real solutions. And then again, since there are no real solutions, there's not really a point to finding them because we can't. So you just say no real solutions. That's supposed to, I guess I should write it out, shouldn't I? Or you can just write none, a little smiley face, yay, we don't need to do any more work. All right, keep going. Number 7. So again, we are going to start by setting y equal to 0. So I get 0 equals 2x squared minus 4x minus 3. Then I'm going to go through and find a, b, and c. So a equals 2, b equals negative 4, c equals negative 3. We want to find the discriminant first, so b squared minus 4ac, and I can plug in the different parts. Again, then you are going to use your calculator to simplify that part. I would not try to do that. Well, you can if you want, but again, the negatives and things, there's a lot to get wrong on that one. So I'm going to figure out my discriminant from my calculator, which I got as 40. And so because that is a positive number, and pretty much the first positive discriminant I've had, at least on this page, we can use the positive rules, which up here say we have 2 real solutions. So I'm going to go through, I'm going to say, okay, 2 real solutions, and then we got to find them. So there's the discriminant, there's the conclusion. Now again, we got to go back to the quadratic formula, but we already know the messy part because we found it as the discriminant. So x equals the opposite of b plus or minus the square root of b squared minus 4ac. We already know that part, 40. All over 2a. Okay, now here is something that makes radicals and quadratic formula more difficult. We have a radical that needs rationalized. And so you have a couple options here. You can take this square root of 40. First off, the square root of 40 is not something nice. I don't know the whole number that would be because it's not a perfect square. So you need to figure out what the square root of 40 is when we simplify it. And again, we learned it earlier in the year. You take a radical, you break it into a perfect square and what's left. So 40 is 4 and 10. So that means that just that part is going to be 4 plus or minus 2 root 10 over 4, because I can finally simplify 2 times 2. And then we have to simplify each of these to get our 2 solutions. So again, just kind of bear with me. You'll get better at this as we practice it more. But I'm going to have 2 solutions. The first one is x equals. Now this is a little funky. What you have to think of is that this is 2 terms being divided by 4. So I look at the first term and I figure out what is 4 over 4. 4 over 4 is 1, plus or minus. And then I want to figure out what this would be. So we can actually, you know what? Don't do that. You can put this in your calculator as well. That's another option. This is the part where I'm going to be real with you guys. A lot of you are going to kind of get lost. So we're going to keep practicing this, but here's what I would do. Okay, it's going to be a fraction. Go through and reduce these if possible. But really, the first thing I need to reduce on this one is 2 over 4. So 2 over 4 is 1/2. So for that part, I'm going to have 1 root 10 over 2. And then we would need to figure out, okay, if the denominator is 2 now, what would this first number need to be? It would have to be 2 as well, because 4 over 4 can reduce to 2 over 2. Essentially, the best way to think about this is you are taking a GCF out of every part of the fraction. So if you look at those coefficients, maybe that's how you should think about it. If you're looking at the first number and then the second number, which is a coefficient on root 10, and then the number in the denominator, if you were to find their GCF and factor it out, you would take out a 2. So this 4 would become a 2, this 2 would become a 1, and this 4 would become a 2. Yeah, think of it that way. Okay, and we would have the positive version, which is this. That is the answer. Isn't that messy? It's so messy. And then I also have 2 minus 1 square root of 10 all over 2. Has the -1. So again, quadratic formula, there is no way to be a math strat quickly because I can easily give you another question like that one where it's like, what the heck is going on? The other thing too, though, use it as an experiment. If you put this in your calculator, see what you get. It should reduce that correctly if you type it in just like that. You cannot type in plus or minus though, so you'll have to do plus the first time and then minus the second time. Whew, okay, number 8. So again, on number 8, we're gonna set y equal to 0. 0 equals -3x squared plus 5x minus 8. Then I need each a, b, and c value. So a is -3, b is 5, c is -8. I can find the discriminant now. So b squared minus 4ac is going to be 5 squared minus 4 times negative 3 times negative 8. So I can find that value, which is going to be negative 71. Now it's a negative. Yay, because when it's a negative, remember, you just have to say that there are 0 solutions or no real solutions. And so you don't even have to solve because we won't be able to. All right, on to the next page. Here we go. So again, we are gonna have some kind of messy answers on this page. Bear with me, you're gonna be fine. We're gonna do okay. All right, so number 9. The problem with number 9 is not only do we not have 0, but also I don't have this equation in standard form. So the first thing I'm gonna need to do is I've gotta move everything either from the right side or the left side. I think I'm gonna move everything from the right side. So let's think about how that's gonna work. I'd have to subtract x from both sides, and I'd have to add 10 to both sides, okay? So I'm gonna end up with x squared. Sorry, now my pen's giving out. X squared. And then we do need to combine our like terms. So I have negative 7x, but I'm subtracting another x, so minus 8x. And then I added 10 to this side, so plus 10 equals 0. That's a little tricky. Then we go through. We find a equals, b equals, and c equals. A equals 1, b equals negative 8, c equals 10. And again, we're asked, what is the discriminant? So again, the discriminant is the part under the radical. I can plug in those values. And then based off the discriminant, we'll have to see what solutions we have. So plug it into your calculator, see what you get. I get that the discriminant is negative 4. Again, you really, really, really need to check that's what your calculator says. So that tells me I have no real solutions based off the page on the previous, or the table on the previous page, and then no solutions, don't need to do any work. That's the last one like that. So don't expect a bunch of those on this page. Okay, so let's do a few more. Again, these can be a little bit tricky, particularly the ones where you have to rearrange them at the very beginning to get it in standard form. So here's number 10. On number 10, I need to replace y with 0. So I get that 0 equals x squared plus 4x plus 1. Quadratic formula. A equals 1. B equals 4. C equals 1. Again, we're just asked for the discriminant for now. So b squared minus 4ac. See what we get? B squared is 4 squared minus 4 times 1 times 1. So then I have to figure out that value. Put it in your calculator. Calculate, 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 calculate. I got out 12. So that's a positive number telling me there are 2 real solutions. Now we need to do the quadratic formula to figure out what those solutions are going to be. So we do solutions, the song. The opposite of b plus or minus the square root of b squared minus 4ac, discriminant 12, all over 2a. Again, a little bit funky because this radical would need simplified. Square root of 12 is nothing we know off the top of our head because it's not a perfect square. So we got to go through and say, okay, well, what perfect square is 12 divisible by? Square root of 4 and square root of 3. Okay, so bear with me. This one's a little tricky. Negative 4 plus or minus. Because of the square root of 4, I'm going to have a 2 in front. And then that's going to be followed by a square root of 3 because that cannot be simplified further. All over 2. Then we do the thing, like I said, I think the easiest way to do it is with GCFs. So imagine yourself looking at those 3 coefficients, negative 4, 2, and 2. What is the GCF that can be taken out of each of them? 2. And then we're going to reduce each of those by that factor. So x is going to equal, okay, negative 4 divided by 2 is negative 2, plus or minus 2 divided by 2 is 1, root 3, over 2 divided by 2 is 1. So those are the answers. Isn't that nuts? It's nuts, okay? Math's a little nuts sometimes. You can write it twice if you want, like the positive and the negative version. I don't know if anybody cares. Typically when they're this messy, I just write it once because it takes up a lot of space as is, but that would not technically be wrong. That would be awesome if you thought to split those up as two distinct solutions. Okay, a few more. I know this is long, I'm sorry. Okay, so number 11, I need to get everything to one side because right now nothing's set equal to 0. So I'm gonna move over the 20 by subtracting it. So I get the x squared plus x minus 11 equals 0. Now we need the discriminant, which we get by finding each variable. So let's see, a equals 1, b equals 1, c equals negative 11. So I can find the discriminant, b squared minus 4ac. So let's see, 1 squared minus 4 times a times c. And then again, that's calculatorable. So let's see, 45. It's a positive discriminant, so I have two real solutions. Again, that's the whole point of finding the discriminant so that we know what solutions we're looking for, how many we should have. And then we're ready for the quadratic formula. So for the quadratic formula, sorry, trying to figure out what colors I used. I get x equals, here we go, the opposite of b plus or minus the square root of b squared minus 4ac, again 45, all over 2a. And this is one, again, where we do have to simplify that radical. So like I've said a bunch of times, remember, we did radicals earlier in the year. A lot of us struggled. But what you do is you divide it by a perfect square. So the square root of 45 can be divided into 9, a perfect square, and 5, what's left over. So x equals negative 1 plus or minus 3 root 5 all over 2. And then again, last but not least, we have to check and see if there's any GCFs. So if negative 1 and 3 and 2 had a GCF, we'd take it out and reduce it, but it does not have a GCF, so that is going to be our final answer. Again, if you wish to write that as two separate solutions, you can, but most of the time mathematicians are happy leaving it because it's already a lot of fraction to write. Okay, you guys are doing so good. There's only 2 more. You're doing awesome. All right, so number 12, again, there is no 0, so I need to move everything over. I think I'm gonna move the 8x over and the negative x squared over. So I'm gonna have to subtract 8x from both sides and add x squared to both sides. Now we gotta watch out for like terms, because on the right side I have 0, that was the point, but I have to put this in standard form. So I notice I have x squared plus x squared. Well, that's 2x squared, so my a value is 2. I only have one x term, it's negative 8x, and then I only have one constant, plus 3. But again, rearranging that and getting that into standard form is a bit tricky. Then I need my discriminant, so my discriminant is b squared minus 4ac. So I can plug in, oh, and I didn't find my values, a equals 2, b equals negative 8, c equals 3. So let's see, b squared, negative 8 squared, parentheses are mandatory, minus 4 times a times c. So let's figure out what that is. Like 64 minus 24, so 40. Again, it's positive, so 2 real solutions. And then we have to figure out what those solutions are. Whew, okay. If you want to try to finish this one on your own and then check back with me, that's a good idea. Otherwise, keep watching. So x equals the opposite of b plus or minus the square root of b squared minus 4ac, 40, all over 2a. So we have to remember we have a radical that needs simplified. 40 can be broken into 4 and 10. So really this is equal to 8 plus or minus 2 root 10 all over 4. And then I need to find the reduced value, because if you look, this, and this all have a GCF in common. They are all divisible by 2. So I need to reduce those by a factor of 2. So 4 plus or minus 1 root 10 over 2. That last step is always hard for people. So if that last step is where I'm losing you, you're doing pretty good. All right, one more. So again, I need this to be set equal to 0. That means I have to move over 6x. So I'm going to have 2x squared. And then let's see, I would subtract 6x from both sides. Uh-oh. There we go. So I get 2x squared. I have 15x minus 6x, so plus 9x equals 0. Now, don't let this fool you. I do not have a C term, but that just means that my C term is 0. So if there is no constant at the end, it's like plus 0, and that is your C term. So then I can go through. I can do the discriminant, which is b squared minus 4ac. So 9 squared minus 4 times a times c. I can figure that out in my calculator to get 0. No, sorry, not 0, 81. Whoops. Which tells me, because it's positive, there are 2 real solutions. And then we can solve with the quadratic formula. So close. X equals opposite of b plus or minus the square root of b squared minus 4ac, 81, perfect square, awesome. All over 2a. Okay, luckily, 81 we know. So it's negative 9 plus or minus 9 all over 4. And then we need to split it up to the 2 different situations. So negative 9 plus 9 over 4 and negative 9 minus 9 over 4. And then let's figure out each of those. So negative 9 plus 9 is 0 over 4, so 0. And then negative 9 minus 9 is negative 18 over 4. Those have a GCF of 2, so I can reduce that once again to be negative 9/2. Okay, you guys are awesome. I know that was a lot, but now you have the notes down. And again, we are just going to continue practicing for a very long time so that hopefully by next year you feel confident and, capable of the quadratic formula. All right, I'll see you guys later.